Okay, in this video I'll solve the problem notated number 5 here. Consider the set T, which contains the elements A, B, and C. We want to write down all the two lists. Now a list has order that can be made out of the elements of T if repeats are allowed. Okay, if I'm allowed to repeat, then I'm going to start with AA. I'm going to move on to AB and then move on to AC. Then I'm going to start with B and take the same pattern. I'm going to go through A, B, and C in the last position. Now I'm going to put C in the first position and cycle through A, B, and C in the second position. And I got 9 of them. And let me go ahead and calculate that number. The number is 2 lists out of a 3 set with repeats is 3 to the 2, which is 9. Okay, so this is like n to the k with n equal to 3 and k equal to 2. Just like the previous problem, I had n to the k for a k list from an n set where repeats are allowed. Okay. And so this is equal to n to the k with n equal 3 and k equal 2. For part B, we're going to do 2 lists where repeats are not allowed. Okay, well, we just get rid of the AA, the BB, and the CC, and I'm going to have an AB and an AC, then a BA and a BC, and a CB, and a follow the pattern, I would start with a CA and then a CB. Notice that I'm putting them in alphabetical order at the in the second position as I cycle through the first position being A, B, and C. Okay, and we can calculate the number of them by saying the number is equal to 3 times 2. We can also say this is P3, 2, which is 3 factorial over 3 minus 2 factorial, which is 3 times 2 times 1, all over 1, which is 6. Okay? You know, what I'm going to do is this is 3 times 2 times 1, all over 1, which is 6. I'm going to leave myself a little bit of room over here to work on part C, which says, write down all the 2 subsets of T and explain how the number of subsets can be obtained from the answer of part B above. Okay, 2 element subsets. There's not too many of them. I can write down A and B. I can write down A and C. And I can write down B and C. There's only 3 of them. And the number is 3. And this can be written as 3, 2 combinations, which is 3 factorial over 3 minus 2 factorial, 2 factorial, which is 3 times 2 times 1, all over 1 times 2 times 1, which is 3. And I can obtain that from that number from the answer to B above by saying that C3, 2 is equal to P3, 2 divided by 2 factorial. And this is the number of lists divided by the overcount factor, which is the number of ways of permuting the elements of those lists. Okay, number of lists divided by the overcount. And then the overcount is in fact 2 factorial, which is the number of ways of rearranging 2 elements. And I can circle them like this. Okay, so there's problem 5. Hope that helps. This is a very important concept.